The most common failure in AI-assisted engineering happens the moment a developer types a quick request, treating their coding agent like a simple search engine. Firing off a one-line prompt and expecting the model to autonomously intuit your architecture usually ends in a predictable trap. You spend more time correcting the resulting code than it would have taken to write it yourself from scratch. The mechanical cause of this failure comes down to a hard physical limit: the finite capacity of the large language model's context window. Everything you paste, read, or generate competes for the same working memory. If you work in a single, unstructured session for hours, the noise of your ongoing conversation accumulates. Slowly, your early structural instructions get pushed completely out of the model's memory. This degradation is known as context rot. As the session drags on, the agent loses its grip on your codebase. Once working memory is overwhelmed, the model defaults to assumptions rather than ground truth, hallucinating variables and generating buggy output. Linear chat interactions fail at scale because they rely entirely on the engineer's memory to maintain systemic constraints. To rely on an AI coding agent for production work, we have to accept that the model is only as effective as the curated context and the strict boundaries we provide it. The engineering focus has to shift away from writing clever, one-off prompts. The real leverage is in building persistent, structural guardrails that constrain the agent's behavior by default. This framework scales in tiers. We start with universal project constraints that apply to every session, scale up to modularizing repetitive workflows, and finally hand off execution to advanced multi-agent parallel orchestration. The highest leverage activity for a modern software engineer is no longer typing syntax. It is architecting the operational boundaries where the AI operates. The baseline standard begins with Tier 1 habits. These are universal, low-effort practices that yield the highest compounding returns over the lifecycle of any project. The most critical habit is maintaining a living CLAUDE.md file at the root of every repository. This is a permanent, version-controlled instruction manual that the agent automatically reads on startup. It acts as a structural filter between your raw code base and the model's working memory. A strong file captures exact conventions for naming, structural formatting, and security patterns. Critically, it must explicitly list what not to do. Documenting specific anti-patterns prevents those errors from recurring. A clever prompt works exactly once, but every time an engineer corrects the AI and updates this file, that specific fix is captured for the entire team. Because this artifact evolves with the project, the agent effectively gets smarter the longer you work on the codebase. Before asking the agent to generate code for a non-trivial feature, you need to draft a short product requirement and technical design document. This allows you to front-load the context. You supply the system stack, the specific task, the expected output format, and a strict definition of what done looks like. From there, you point the agent to exact file dependencies and specific line numbers. You do not ask for conceptual updates. You direct it to the exact location of the work. Every prompt must close with a negative boundary limit. Saying, "do not update anything else," locks the model into the exact scope. Without this boundary, broad prompts trigger unrequested refactoring. The model sprawls into adjacent files, introducing untested changes. Broad constraints produce risky, unpredictable code. Narrow, explicit constraints produce trustworthy changes. Spending 3 minutes assembling the context and setting the boundaries up front is drastically cheaper than spending 3 hours debugging an overly ambitious agent. Once the baseline constraints are in place, we can scale to Tier 2 workflows, targeting repetitive, multi-step engineering processes. Any task performed more than twice, like incident triage or cross-service investigation, should be modularized into a skill. A skill is a reusable markdown file encoding a fixed workflow. It demands explicit inputs, dictates a rigid sequence of execution steps, and requires a defined output template. To maintain clarity during these complex workflows, you must manage session state. Periodically prompt the agent to summarize its progress, clear the context window, and paste the clean summary back in to eliminate accumulated noise. You also route tasks intelligently based on complexity. You save expensive reasoning models for architectural problems and rely on fast, lightweight models for boilerplate generation. Modularizing workflows into skills eliminates prompt ambiguity, removes repeated fact-finding, and guarantees a deterministic, consistent output every time the task is run. Tiers 3 and 4 abandon the linear chat paradigm entirely, moving into complex orchestration. In this architecture, the main agent thread acts strictly as an orchestrator. It handles coordination and summaries, but it writes zero code. Instead, the orchestrator delegates execution by spawning multiple parallel subagents to do the actual development work. Each subagent is assigned a strict, isolated context boundary tailored entirely to its specific slice of the project. This isolation is critical. It prevents the active subagents from polluting each other's working memory or hallucinating features across different project scopes. But autonomous generation requires an equally robust safety mechanism: adversarial auditing. You cannot trust a builder to audit its own code. It shares the same blind spots. So the orchestrator spawns an adversarial agent. Its sole directive is to hunt for edge cases and aggressively break what was built. This architecture solves massive operational bottlenecks. In one instance, a team used it to execute a complete security audit across over 1,600 files. By batching the repository into groups and unleashing parallel subagents on those clusters, a task that normally took days of manual review was completed in roughly 10 minutes. For end-to-end pipelines, you implement confidence scoring gates. The AI calculates its own certainty, allowing low-risk steps to run autonomously while pausing complex findings for human review. Removing the human from the manual execution loops for well-understood steps accelerates project throughput to a level impossible to match with traditional coding. When developers elevate themselves from writing lines of code to orchestrating parallel agents, their development velocity scales exponentially. This framework operates as an assembled stack. Filters sit at the base, modular skills in the middle, and the orchestrator tree at the top. This automation depends on the structural integrity of baseline constraints. Without them, the multi-node tree collapses. Teams should never mandate advanced sub-agent pipelines until the baseline habits of explicit constraints and upfront planning are universally adopted by every engineer. The role of the modern software engineer changes. They are architects of context and managers of constraints, directing logic rather than typing syntax. Build the persistent guardrails first. Control the context window, and reliable, scalable automation will naturally follow.